Alright, so pH and pOH. So before we get into pH and pOH, let's just go over what the autoionization of water is. So basically, you'll remember that H plus ions cannot exist in aqueous solution because they turn into the hydronium ion, which is H3O plus. So that's the main principle for the autoionization for water. You're going to have H2O plus H2O is going to give you hydronium and hydroxide ions in a reversible reaction. So at 25 degrees Celsius, the concentrations of hydronium and hydroxide are both equal to 1.0 times 10 to negative 7 moles per liter. And your ionization constant of water, which is Kw, is going to be equal to the product of concentrations of H3O plus and OH minus. So your Kw is going to be equal to 1.0 times 10 to negative 14 molarity. So you derive this number by multiplying the concentration of H3O plus and OH minus, which is just 1.0 times 10 to negative 7 squared. So now for a quick review on neutral, acidic, and basic solutions. So a neutral solution is going to have counteracting charges of the acid and base, so it's going to fully neutralize. So you're going to have a concentration of H3O plus equal to the concentration of OH minus. For an acidic solution, your concentration of H3O plus will be more than that of the OH minus, and the number of moles of H3O plus will be more than 1.0 times 10 to the negative 7. For a basic solution, your concentration of hydroxide ions will be more than your concentration of hydronium ions, and the number of moles of OH minus will be more than 1.0 times 10 to negative 7. So for strong acids and bases, they're going to dissociate completely in your weak aqueous solutions. So now for the important question, what are pH and pOH? So pH is basically the potential of the hydrogen ion, which is H+, or hydronium ion, which is H3O+. So pH is used to measure the acidity of a system, and the mathematical relationship between pH and the concentration of H3O+ is on a log scale. So for pOH, that's the potential of the hydroxide ion, which is OH-, and this is also represented on a log scale, and we'll get into what that means in a little bit. So for measuring pH and pOH, they're both measured on a log scale. So if you remember from math, logs are basically just a way to measure things, and for chemistry, we're going to be dealing with base 10. So our pH formula is going to be pH is equal to the negative log of the concentration of H3O+. And the opposite of that, from the concentration of H3O+, that's going to be equal to the anti-log, which is 10 to the power of negative pH is equal to your concentration of H3O+. For every unit change in pH, your H3O+ will change 10 times because you're in base 10. So as the concentration of H3O+ increases, your pH will decrease. So a lower pH is going to be more acidic, and a higher pH will be more basic. So you can measure pH with either pH paper or a pH meter to qualitatively or quantitatively measure a pH. For measuring pOH, it's very similar to measuring pH. The pOH is going to be equal to the negative log of the concentration of OH- ions in solution, and it's on a base 10 scale. The reverse of this is going to be that the anti-log, 10 to the power of negative pOH, will be equal to the concentration of OH- ions in solution. For every unit change in pOH, the concentration will change by 10x because you're on a base 10 scale. So as the concentration of OH- increases, your pOH will decrease. For any aqueous solution at 25 degrees Celsius, your pH plus pOH is going to be equal to 14. So we derive the number 14 from our autoionization of water constant, which was 1.00 times 10 to the negative 14. So we get that our pH scale will be from 0 to 14. Obviously, you can have something that's below 0 or above 14, but generally we'll be dealing with numbers that have a pH from 0 to 14. So then how we got to 25 degrees Celsius is our standard state temperature. So you'll remember from chapter 11 that STP, which is standard temperature and pressure, was 0 degrees Celsius, but this is standard state temperature and it's 25 degrees Celsius. So make sure you know the difference between standard state temperature and standard temperature and pressure, which is just 25 degrees Celsius versus 0 degrees Celsius. So now we're going to go over some questions for pH and pOH calculations. So question number 1, apple juice has a pH of 3.76. Calculate the concentration of H+ ions. So notice that I said H+ ions, but it could also be H3O+ because it's going to be the same in an aqueous solution. So feel free to pause the video and work that out, but here's the solution to that problem. So we have the pH is going to be equal to the negative log of the concentration of H plus or H3O plus ions. Since we've been given that the pH is 3.76, we're going to use our anti-log formula. So we have 10 to the power of negative 3.76, where 3.76 is our pH, and that's going to give us 1.7 times 10 to the negative 4 molarity for our final answer of the concentration of H plus. So you notice how we just reversed the formula to get the pH, to get the concentration from the pH, and we can also get the pH from the concentration by going the other way. So our next question is calculate the concentration of H3O plus of a solution with A 0.010 molarity of OH minus and for B 1.8 times 10 to negative 9 molarity of OH minus. So feel free to pause the video here and work through the problem yourself, and we'll go over it in the next slide. So here we have our worked out solution. So what we know is that the constant of the product of these two concentrations of H plus and OH minus is going to be equal to 1.0 times 10 to the negative 14. So once we know that, we can just divide 1.0 times 10 to the negative 14 by our concentration of OH minus, which was given to us as 0.010 moles per liter. So once we divide those two numbers, we're going to get 1.0 times 10 to the negative 12 molarity as our concentration of H plus. So you'll notice for this solution, the concentration of OH minus is more than that of the H plus, so it's going to be a basic solution. For our second example, we're going to do the exact same thing, dividing our constant of 1.0 times 10 to the negative 14 by 1.8 times 10 to the negative 9. And our answer for this is going to be 5.6 times 10 to the negative 6 molarity. And in this example, we'll notice that the concentration of H plus is more than that of OH minus, so it's an acidic solution. Our last question here is, what is the pH of a 0.028 molar solution of sodium hydroxide? So once again, feel free to pause the video here and work the solution out yourself, and I will go over it in the next slide. So one thing you'll notice about this problem is that you were given the molarity of sodium hydroxide. So if you remember from our bases video, sodium hydroxide is a strong base because it has the group 1 cation of Na+, and it'll form hydroxide ions in solution. So now that you're given the molarity of that, what you want to do is convert that into pOH and convert pOH into pH. So the main concept we're using in this question is that pOH plus pH is equal to 14. So we know that, so we can just calculate our pOH first from the molarity, which is the negative log times the molarity of OH minus ion. So that's going to be the negative log of 0.028, which is equal to 1.55. And for our pH, that's just going to be 14 minus 1.55 is equal to 12.45. So in 1dA, we have 14.00 minus the negative log of 0.028 is equal to 12.45, and that's our pH value. So I hope you enjoyed watching this educational video on pH and pOH from chapter 15. If you have any questions or if you just want more practice problems, feel free to leave a comment on this video, and I hope you have a very nice day.